implicity differentiation. We have two questions here. Find the dy dx for x to the power 3 plus x plus y to the power 3 plus 3y is equal to 6. And B says 4xy squared plus 6x squared over y equal to 6. So how do we implicitly differentiate a function? So to differentiate a function implicitly, we need to take into consideration both x and y. That's what it means. So I'll show you. But because we are differentiating something with respect to x, so here is where the trick comes in. Okay. So for a, okay, we have x3 plus x, isn't it? Plus y to the power 3 plus 3y is equal to 6. Alright, so how do you differentiate x to the power 3? It will just be 3x squared, right? Plus the derivative of x is just 1. Now, this is not x, but it is y. So we are going to differentiate the same way we can differentiate x, which will be 3y squared, but we are going to add dy dx because we are not differentiating, because we are differentiating this one in terms of y. So in terms of x. So dy, you add dy dx here. Plus, same thing applies to here. What's the derivative of 3y? It's just 3. But because there's the term y, we add dy dx. What's the derivative of 6? 0. Our main aim here is to take out dy dx. So we get 3x plus 1 plus, okay, we can take out dy dx here. Let me just bring in enough space there. Plus 1 plus. So we can factorize dy dx because it's common, you can see, right? So we remain with what? 3y squared plus what? 3 equal to 0. And now here you can see that we can now take this part here, the other side of the equation, right? So let's do that. So we remain with dy dx of 3 squared plus what? 3 is equal to negative 3x squared minus 1. Then look, what do? We want to remain with dy dx. Right, we divide now throughout. We do what? You divide 3y squared plus what? 3. 3y squared plus what? 3. So eliminate, and your dy dx will just come out naturally. Okay, you don't even have to force it, no? It will come out naturally. Let's look at B. B is a combination of the product rule and the quotient rule. If you've looked at the question nicely, because it says 4xy squared plus 6x squared over y equal to 10. This part here alone here can be done using the quotient rule, and this part here can be done using the product rule because we've got x and y multiplying each other. So how do we do the product rule, ladies and gentlemen? So we have 4 is a constant. All right, if you want, you can say 4x and y squared. So here, just here, you can say let u be 4x and let v be equal to y squared. Also at this particular, also this side here, you can say let u be, well, maybe 6x squared and v be equal to what? Y. So now, this part, let's apply product rule. So we keep u, we differentiate what? V. Differentiating v will give us what? Okay, will give us, we are multiplying them, remember? Let me do this, we are multiplying them. You know the product rule formula. Okay? u, v plus v, u, like this. You know it, that's what we are doing here. So because we are multiplying them, let's show some multiplication there. So differentiating this one, we get 2y dy dx. Okay? Plus, we are done with uv prime. Next we go to v, we keep y squared, 9. So the 4 is common. let me just say the 4 is common, ladies and gentlemen. Okay, so the 4 will be there. No matter what, the 4 will just be there. So we have 4. Okay, because if I differentiate this one, I'll just mean what? 4. Then v squared is there, so I squared. So I'm done with part 1. So I'm going to add another plus, then I'll introduce the brackets. Here, how do we do? We differentiate this one. What do you mean with? 12x. Let me write x here, mush. 12x. Differentiating this one here, we keep this one. Okay? That's how it's done. So you differentiate. Okay? You keep. I don't know if it's making sense. You differentiate, you keep. So we keep minus. We keep this guy here. We keep 6x squared. We differentiate y. What's the derivative of y? It's just 1, but it will be 1 dy dx. Oh, by the way, is equal to 0 because the derivative of 10 is just 0, right? But over everything here will be divided by v squared, which is y squared. This one here. That's the formula for the quotient rule. Well, we can now subtract now. Oh, sorry, evaluate this. So here we have 4, sorry, not 4, but 8 8xy dy dx. We have 4y squared plus. Okay, so check out here. We have 12xy. We can separate the division and do this. Minus 6x squared dy dx over y squared. Our main aim is to take out dy dx, and we are going to do that slowly by slowly. Dy dx plus 4y squared. Y can go there, so we have 12x over y minus 6x squared over y squared dy dx. This one is equal to 0, is equal to 0. Are we there? So now, these two, this one and this one, can be grouped so that we can take out dy dx. So let's do that. So we get, so when I remove dy dx and dy dx there, I'm going to have dy dx, open brackets, I'm going to have x, 8xy. Here I'm going to have minus 6x squared over y squared. And I'm going to have plus 4y squared plus 12x over y equal to 0. Then these can be taken the other side. Okay? These here can be what? Taken the other side, so that we can just now come and divide it throughout. It's an interesting question, so let's do that. So if we divide throughout, so this one goes to the other side, you have negative squared minus 12x over y over 8x minus 6x squared over y squared. This is your dy dx. If you want, you can further simplify it. It's really up to you. And should we leave it here, or maybe we further do the needful? If we're going to do the needful further, all what I need to do is anyway, we have there, we have the upper part and the down part. That's what we are having. So it will be quite a longer one, so I'll just leave it here. If you can go further, please proceed. But I hope you've known the procedure now. Cheers.